Good morning, everybody. Thanks for joining our session. And I'm Alessandro Sforzin. I am the work package leader of work package 5, which is the work package responsible for CyberSec4Europe demonstrator cases. I have to apologize, but Big Blue Button tells me that my camera is not, for some reasons, available. So probably will not see me. Anyway, what are the demonstrator cases? Oh, now it works. And I also think that somehow I lost. Sorry, this for this. Okay. What are the demonstrator cases? So the demonstrator cases are solutions to the cybersecurity challenges that the project has identified in the selected industrial sectors. And the role of our work package is to implement these solutions and to validate them against their target users, which might be in the industry or simply citizens in the society. Our work package must also closely collaborate with two others in the project, the research and development work package and the research roadmap work package, so work package 3 and work package 4. And concretely, through the use cases that our work package has defined for the demonstrators, we provide requirements that the research carried out in the project will use as guideline for their work. And in exchange, we take the research results and integrate them in the demonstrator's functionalities. And here is a very familiar picture to CyberSec4Europe partners. I wanted to give you an idea of how work package operates. And as you can see, the life cycle of the project is structured in 2 big cycles. And the rationale here is that we take the lessons learned from the first cycle and we use them to improve our work during the second cycle. The end of the year now signals the end of the first cycle, which is a milestone at which the demonstrator's first prototype should be ready. And these are the demonstrators, so the 7 verticals that we are working on: open banking, supply chain security, privacy preserving, identity management, incident reporting in the financial sector, maritime transport, medical data exchange, and smart cities. And they are all working to implement this innovative solution, also collaborating with experts in the industry. But given the time today, we are going to present to you only 3 of them. Open banking, presented by David Goodman from Trust in Digital Life. The maritime transport demonstrator, presented by Spiro Papastergius from the University of Piraeus. And the smart cities demonstrators, presented by Vincenzo Savarino for engineering informatica, assisted by Antonio Scarmeta from the University of Murcia. And what we're going to show you, it's not the final complete version of the demonstrator, because not all the functionalities have been implemented, because again, this is just the end of the first cycle, but their current status should be enough to give you a pretty good overview of their goals and their capabilities and what we plan to do in the future. So I'd say that without further ado, we can already start with the open banking demonstrator. So David, if you want to.
Thank you, Alessandro. And the good news is my webcam is working today. So we're going to talk about open banking, and we're going to do this in 3 or 4 different parts. First of all, I'll give a brief introduction. Then Médéric Collas from Group BPCE in Toulouse is going to talk the business case. Erwan Dano, who is also from BPCE, from Banque Populaire, is going to talk about the architecture, and then we're going to do a live demo involving Erwan and Ramon Martin de Pozuelo from CaixaBank, and also Médéric. So first of all, open banking. For those of you who are not familiar with open banking, it represents a new wave in the financial community in terms of banking transactions, including payments. It's very much related to the EU directive on payment services, the version 2, PSD2, and the GDPR. In terms of PSD2 attempts to open up the banking industry, making banking transactions transparent to third parties in ways which have never been done before, primarily through APIs. And as we know, the GDPR is there to respect the rights of citizens from too much exposure of their data. So there is an inherent contradiction between what PSD2 is trying to achieve and the GDPR. There is much more written about this in some of our deliverable reports on road mapping, as well as the WP5 that Alessandro was referring to. So one of the demonstration use cases within open banking is Obsidian, which stands for Open Banking Sensitive Data Sharing Network for Europe. You can see why we made it an acronym. And what we're attempting to do here is to support the fight against fraud by sharing information between banks without revealing sensitive information, either about the fraud itself or about the banks involved. And the objective of this is to be more effective in detecting money laundering, so AML 5 or terrorist financing. And this would protect the overall economy of the European market. So I'd like to hand over now to Médéric, who will give an explanation of the business challenge. Médéric, to you. Médéric, have you unmuted? It looks like Médéric is not there. He was a moment ago. So basically, the PSD2.
David, can you hear me?
Okay.
Sorry.
Go ahead.
Okay, so what kind of challenge are we trying to solve today with Obsidian? Today we observe that a growing part of the major part of the successful banking fraud now relies on human weaknesses. This means that while thanks to DSP2 work, it becomes more difficult to impersonate final users in banking application. Misleading them has become the easiest way for fraudsters to succeed. Nevertheless, the final step of any successful fraud is still the same: exfiltering money through the transfer to a bank account controlled by the fraudster. These frauds are globalized. This means that today a fraudster, for example, can use the same documents to open several accounts in several banks and use the same IBANs, for example, to commit several frauds without being worried about being unmasked. In the meantime, banks try to build and train fraud detection systems with very poor data because they don't share anything. But good news, we already know that sharing fraud data is possible and useful because, for example, security and fraud detection services delivered by external technology providers like IBM Trusted, for example, are already based on this principle. By contracting with a major part of banks, collecting and correlating their data, they are able to produce powerful fraud insights. So the Obsidian project aims at implementing, if you can go to the next slide, David. The Obsidian project aims at implementing a fraud information sharing platform for open banking sector, but with two key points that make the difference. First, sovereignty of each participant on its own data is preserved. This means that each data to share is pseudonymized before being stored in a specific local database, and the central server ensures the connection between these different local databases to create a virtual data set which can be requested by any of the participant programs. And secondly, shared data are business data. I mean signatures of IBANs and documents used by fraudsters. And sharing this kind of data becomes possible thanks to latest innovation in the field of cryptography. So each bank today owns a list of IBANs qualified as fraudulent through internal processes. And the first step of Obsidian project is to succeed in merging these lists into a virtual dataset that each participant can request through Obsidian Central Server. So let's see how it works. Erwan, if you can take the next slide. Erwan?
Unmute.
Hello.
Yes. Okay, we hear you.
Yes. Can you hear me?
Yes. Yes.
Okay, so here we explain how the architecture works. Basically, we have a central server that will relay the request between the participants, which are the banks. So when a bank A wants to know if an IBAN is dangerous, the bank will protect the IBAN with pseudonymization techniques and then send the request to the central server. The central server relays the request to the participants who are connected because the central server knows who is connected on the network. When the bank B and bank C in the diagram receive the request, they use their pseudonymized fraud data database to craft the response and send it back to the Obsidian server. The Obsidian server then relays the response to bank A, which now knows if the IBAN that was requested was seen in a fraud in bank B or bank C. All of this is done without any of the participants having knowledge of the data behind the request. So it's a kind of a zero knowledge proof. So it's difficult to explain all the technical aspects of the protocol in a given time, but the important features we have to remember is that the data exchange is always pseudonymized, so never exchanged in clear text. And the second important feature is that the central server does not store data. Each bank keeps the total control of the data. So we can move on to the next slide. So this architecture design, coupled with the cryptographic technologies we use, are bringing three desirable properties. The first one is that we are compliant with the GDPR and banking secrecy. The second one is that because we are compliant with banking secrecy in the most restrictive countries, we know we can expand the architecture and the network into a European network very easily. And the third one is that, contrary to MISP integration, the data is never handed over. Banks always keep control of the data, and they can easily add or remove an IBAN when necessary. So we can move on to the demonstration now. If you can, David, you can give me control.
Yeah, you can share your screen now, Erwan.
I don't see the. I'm connected with two. Can you give the presentation rights to Erwan Dano, not Erwan Dano Group BPC, because I'm connected with two computers. Sorry, because I had a problem with the audio.
Okay. You should be good to go now.
All right. So you should be able to see my screen now. Okay.
Yes.
So what you're seeing is the prototype we have developed right now. In this demonstration, we show how multiple banks can share fraud information within the Obsidian network. Médéric will play the role of another bank, and we have a special guest, which is Ramon Martin de Pozuelo, part of the security innovation and digitalization team at CaixaBank, one of the largest bank in Spain, and who also takes part in Concordia and CyberSec4Europe. So thank you, Ramon, for taking part in this experiment, because it shows that we are already capable of working with other European banks.
Welcome. It's a pleasure to be here.
So you can see the Obsidian prototype is entirely built on web technologies. Here I'm playing BPC expert. I enter my alias, but this is not needed in production. Here you can see the number of participants. We have 3 participants, and above the number of shared IBAN. I'm not sharing any IBAN now, so let me add some IBANs. I'm going to put in my BPC TXT file, which contains 1 fraudulent IBAN per line. I put it in the import process, which verifies that the IBAN are correctly formatted, and then proceed to the data pseudonymization. So here, each IBAN is being hashed and encrypted with our secret key that we never give up to anyone. So the data really stays protected during the transmission. Moreover, here every computation is done entirely into the browser, so nothing is sent to the server right now. Everything is done locally, which improves the protection process. So now I'm about to, I finished protecting my IBANs. I think Ramon and Médéric should have loaded the files.
It's the case for me.
Okay, I'm doing it already.
Okay, so I'm going to move on to the rest of the demonstration. So now what I want to do is try if an IBAN is known as fraudulent by another bank that is connected. So I put in my IBAN there. I click on the check button that will send a request, as we've seen already in the diagrams. So I send the request. I wait for the responses. One is from user Caixa, another one is from other bank, and here I have my response that it is a dangerous IBAN. From the right side, you can see that I have a history of what happened. I sent a request there. I got 2 responses, and one of the 2 responses told me that the IBAN I I sent in my request was already seen as a fraudulent IBAN by another bank. In production, this won't be we won't know if the response comes from Caixa or another bank. All the participants will stay anonymous, and that's a prerequisite to keep the banking secrecy protected. So I can show you what happens if I try an IBAN that is unknown. The same thing will happen. 1 request, 2 responses, but this time we don't know if the IBAN has already. Actually, it's not that we don't know if the IBAN has been seen. We don't know if the IBAN is fraudulent because nobody has seen it in the fraud already. So this light version of the web client does not require any installation. You can visit the website if you have the credential and use it any day. We plan on building a very deeply integrated prototype with a rich client that can be integrated in the bank's automated system. That concludes the demonstration, David.
Great, thank you, Erwan. That's the end of the Obsidian presentation. And I'd like to now hand over to our next presenter, who is Spiros, who is going to talk about maritime transport. And I will just make Spiros presenter.
Hello, can you hear me?
Yes, we can hear you.
Okay, so good morning, everyone. My name is Spiros Foster-Giu. I'm a researcher at the University of Piraeus Research Center. My presentation will emphasize the energy to protect the maritime ecosystem. Okay, so as you can see in this slide, this maritime ecosystem is a very complex environment and system with various players, actors, including shipping companies, maritime ministries, custom agencies, shipping organization, and so on. So all of these collaborate in order to support a number of operations and establish a dynamic environment. Actually, this ecosystem can be considered as a globally distributed and interconnected process that involves domestic and international transportation, information technology, warehouse, among others. In the digital era, the maritime ecosystem and the maritime sector in general, has experienced a massive digitalization. Nowadays, most of the stakeholders are operating upon ICT component, complex IT infrastructure, new technologies such as IoT devices, cloud computing, and big data technologies in order to support a number of services such as LNG services, tanker transportation, vehicle transport services, passenger and cruise services. However, the increased usage of this information technology, as well as the increasing the connection between the different devices, has transformed this operator into large critical information infrastructure. As you can see in this slide, it should be noted that this valuable interconnected infrastructure have become target of several attacks, attracting the attention of various types of criminal malicious entities, such as hacker, criminal gangs, cyber hacktivist organization, and so on. In particular, over the last year, this organization and this infrastructure has received front-page attention as victim of cyber attack. A number, for example, of ransomware and WannaCry attack has been taken place with major European and international maritime organizations such as port authorities, shipping companies, among those that have been hit hard. In particular, these maritime organizations have experienced major attack, affecting the majority of their operational system. According to survey in 2018, 50% of the maritime organization worldwide were victim of cyber attack. Obviously, the massive digitalization of this sector has changed the threat landscape. So now these critical infrastructure are becoming more vulnerable to cybercrime. Therefore, there is emerging need for new innovative approach that facilitate the identification, analysis, assessment, and mitigation of both organization-wise and independent threats and risk. In addition to that, there is a need to harden the security of the maritime system and software and to secure the communication between them. So in this context, the aim of our demonstration case is to contribute to the effective protection of this maritime ecosystem arising from the connection, the dependency that exists between different types of organization and entity. Within the scope of our demonstration scenario is to implement a number of cybersecurity services that will ensure high level of security for various critical transportation operation and processes, covering several research challenges, as you can see here in this slide. For example, early identification of an assessment of risk, threat, and different attack scenario for critical maritime system, security hardening of maritime infrastructure, including cyber and physical systems such as sim navigation and communication system, in order to make them more resilient to cyber attack. Also, the creation of a secure and stable communication channel for enhancing the maritime system communication security. In this context, as you understand, we are planning to deliver and to develop four main group of cyber security services. The first group of services is threat modeling and risk analysis services that are able that give the possibility to operator to identify and assess novel threats, cascading effect, dependent threat coming from the dependent organization and system. So this service enables the actors to model their continuously evolving threat landscape and to assess the risk, threats, and formulate an appropriate mitigation strategy. The second group of cybersecurity services is the maritime system software hardware service. This service will develop the appropriate software hardening mechanism that can be applied to various maritime systems running on different actors, entities such as vessel, port authorities, in order to make the existing bugs and the security weakness of the maritime system not exploitable from various type of malicious entities. The third group of services, the secure maritime communication services that will provide mechanisms in order to ensure the integrity, confidentiality, availability of vessel to vessel, vessel to port, and port to port communication. And last but not least, we're going to develop a trusted environment. Actually, we're going to establish a PKI infrastructure that enable all the enabling actor authentication and facilitating the secure exchanges of information. Now, we have prepared a video where we are going to demonstrate the main feature of these two services. I don't know, David can. Okay, thank you very much. So let's assume that the vehicle transport service is a representative example of maritime transport service that rely upon a highly connected and automated system and technology. So our system support all the IT expert of the stakeholder to enable them with the necessary tools and functionality required to efficiently identify and assess the risk. In particular, the system, as you can see here, allows the creation of an IT asset inventory of all computing and networking related devices owned, managed, or used by the operator, along with their dependencies. And as you can see here, provide a visual representation of their IT infrastructure. Also, the system can act as a comprehensive dictionary of known threat as well as the corresponding mitigation control that can be used to advance operator understanding and enhance their defenses. In addition, the proposed system can act as a central repository of all custom and known vulnerability as retrieved, and these vulnerabilities are retrieved from online repository as needs. The system also armed the operator with a knowledge-based method for modeling all the components of the maritime transport ecosystem. In particular, they are able to identify the primary maritime entity involved in the services, the asset used for the provision of the services, along with the mapping between the services and the infrastructure. The system also aims to provide guidance to the operator on how they can assess and organize the security issues associated with the maritime environment and the services in which they involve. So the operator can use the system in order to identify their cyber threats. They can evaluate their individual vulnerabilities. They can estimate the potential impact derive their corresponding risks, and also they can help them to select the most appropriate control in order to deal with their risk. Finally, the system incorporate a novel attack generation algorithm that take into account that relies on unique characteristics, take into account the dependencies that exist between the different assets, the weakness that exists that their assets have, and the dependencies in order to calculate all the possible attack scenario. Here you can see the PKI solution that have been developed by SINDEF in order to protect the digital communication in maritime sector. This solution includes several operation processes, such as enrollment, in which an entity applies for and receives an X509 certificate. The loading phase, which the certificate is distributed and loaded to the entity. The revocation, the expiration revocation processes in which the certificate run out of date and are renewed and revoked. So can we go please back to my presentation? Okay, thank you very much. Can you go to the next slide, to the last one? Okay, thank you. So finally, here I'm going to present you some relevant research challenges for maritime transport cybersecurity that will be covered the next year. We're planning to enhance the existing risk assessment methodology with more evidence-based and scenario-based approaches based on incident cybersecurity, existing cybersecurity incident, on attack, real attack scenario. Also, we are going to optimize the attack generation algorithm based on novel machine learning techniques in order to provide more accurate result and enhance the visual capabilities of the visual representation, probably, of the attack path. Also, our research plan is to work on methodology and tools for software analysis and identification of unsafe components, to work on program hardening with not recompilation and without modification. Also, a major challenge is to ensure the resilience of the maritime system, because this system needs to continue to work during and after a cyber threat and attack. So our research goal is to develop algorithms that will enable this maritime system to withstand unwanted event, and algorithms that help the operator to analyze all the threat-related information. Finally, work still remains to be done to protect the application data that is transmitted, that are being transferred over the communication channel. So to this direction, our research goals are aimed to develop wireless access control mechanisms through secure channel, also to develop a trust infrastructure that take into consideration the environmental limitation of the maritime sector, transport sector, to implement maritime systems that utilize both satellite and radio communication means, and finally, to demonstrate the trusted infrastructure facilitate preservation of the integrity, confidentiality aspect associated with the maritime communication. So in this way, we are planning to contribute to the to enhance the resilience of the maritime transport sector and environment in general. So thank you very much.
Thanks, Spiros. I guess we can go over to the smart cities demonstrator. So Vincenzo, if you're here, please take over.
Good morning. Can you hear me and see?
We can hear you. I think the camera is loading, so you can start already.
Okay. Good morning to everyone. And I'm Vincenzo Savarino. I'm a senior researcher in engineering informatica, and I'm responsible of smart cities. Is another vertical of demonstration cases involved in CyberSec4Europe project. Regardless its application fields, mobility, building, smart lighting, and so on, a fundamental point of creation of smart cities is the generation, collection, analysis, and sharing of a large quantities of data, not only related to the environment, but also to people, in order to provide a more efficient and personalized services. However, this smart cities process puts individuals at risk, thus reducing its trust. Taking into account this aspect, the smart cities demonstrator case move around the personal data exchange by focusing on two main goals. Sorry, I have some problem to switch the slides. Oh. Okay, sorry. The first one is to set up and put in operation a user-centric infrastructure to support sensor and other Uber data platform for identity and personal data exchange in compliance with the GDPR. The second, to set up an open innovation cycle that will drive the city stakeholder from cybersecurity risk and needs assessment to the identification of a related solution. By achieving these goals, the Smart Cities demonstration contributes to one of the main objectives of the project, to pave the way for a cybersecurity competence center of smart cities. On this end, the Smart Cities demonstration case will be supported by OASC, the International City Network Open Agile Smart Cities involved in the project. In order to address the smart cities security and privacy objective, a set of challenges have been identified in collaboration with the other work packages of the project. In this context, the demonstrator of Murcia, Porto, and Genoa will focus on implementing and putting in operation some of the use cases we have defined by deploying, testing, and validating some of the solution prototype developed or analyzed in the project. The next step is to continue to share other solutions and to scout other solutions in order to validate in the context of smart cities. In the second stage also, the demonstration case will include a dedicated environment by leveraging the city-by-city catalog provided by OASC. The catalog enables to exchange among the cities solution, experience, ideas, and approaches already applied in the cities to be replicated in other cities. Now we present some results of a demonstrator case related to Genoa and Murcia. In particular for Genoa, a demonstration case has been identified to validate a user-centric management of cities and personal data in compliance with the GDPR, and at the same time to provide, in an integrated manner, a support to the user to have more control on their privacy and on how personal data is managed. In this first stage, we first analyze the entire process of collection, conservation of privacy consent. The municipalities offer multiple services to the citizen by means of an online service portal, collecting user consent for the use or reuse of personal data before actually providing the service. In this context, we have decided to adopt the CAPE, an open source user-centric solution, as a central mechanism for managing consent, and at the same time to give the citizen a means, a dashboard, to exercise their rights as data subjects. The demonstrator will further extend by integrating other solutions identified in the project. In particular, we analyze how to translate the legal basis into enforceable access rules. Also, at the same time, we are extending the use case to cross-border scenarios where a European citizen can access to the smart service by using eIDAS authentication. Now I'm showing you a small video of the entire process we have already implemented in Genoa. I just said we have introduced the solution inside the service portal of Genoa, and we have integrated with Speed. Speed is the Italian scheme of eIDAS with the two-factor authentication, and this permits to have a unique identification system. Before to access to the service, can stop, okay. Before to enter in the service, the user is asked to provide some information or to modify the information already provided by the identity system. This information can be reused by the service, for example, to reuse it to other service or to provide a personalized experience. After entering this data, the user is asked to confirm the privacy disclaimer and the consent. This consent is generated automatically by a formal and semantic representation of a consent, by describing which are the processing, which are the type of data, for which purpose, and so on. This permits to store a certificate of the consent and to be used not only for the data processor, that is the service portal, but also by used by the user by means of a dashboard to modify the consent. In fact, the user, after accepting the privacy disclaimer and modify and accept some option of consent, this consent is stored and mutual encrypted and signed by the user and the system, and the user finally can access to the system. In any moment, the user can modify the consent by means of a dashboard. This dashboard lets to know how personal data is stored, for which purpose, which type of processing, see the timeline of events on personal data, and in particular can modify the consent. That is, can view the status, which are the processor, which how personal data is processed, and in case to modify the option already provided. For example, changing which type of data can be shared. Once the user can change the consent, this is consent forwarded to the data processor, the portal, and the different processing can be done according to the new consent modified. I finish my demo, and now I pass the floor to Antonio in order to describe the results of Murcia.
Okay. You. Thanks, Vincenzo. So you give me the role of presenter, please. Okay, thanks. So let's move then to the next presentation. This is the next part, basically. In this case, it corresponds to the Murcia Smart City Platform integration. So basically here, our intention has been to try to integrate over existing, I would say, smart city platform. That is it's called Murcia. It's the smart city platform of the city of Murcia, where already, I mean, there are several services already are available for the citizen. But here, what we have tried is to integrate the possibility of having privacy preserving mechanisms being integrated, so that the user can be in control of what kind of attributes they are able to provide to the services in order to receive the corresponding access to them in that sense. For doing that, as you will see later, we have integrated not only a new, I would say, platform for in the platform, a new privacy preserving identity management mechanism, but also we have integrated the integration with the ADAS, with the idea that we can also authorize the user based on the use of ADAS, thinking about mobility or people that are visiting the city and want to be able to access also to the same kind of service. At the end, for this demonstrator, we have created three different I would say approach. One where it's a service where it can be accessed for anyone, so there's any kind of restriction over it. Other one where it is being requested that the user that is accessing the service is over 18. In this case, for example, is for looking for a parking slot on the city. We assume that for having if you are looking for a parking, you need to have a car driver license. So basically, you need to be above 18. Another one where basically you need to be a citizen of Murcia in order to get information about the water counters regarding the city, for example. Okay, so in order to do that, as already mentioned, we have already put in common in the bottom part, you can see the existing platform that is already available. It's a fireware-based platform where basically all the services are being integrated, where already there was an authorization mechanism being integrated based on the capability access control solution in that sense. And what we have extended is that functionality with, in one side, what you can see here, I mean, it could be the application that's the one that is in charge of doing the connection of the user to the services and is connected through a bridge through a key rock. This is another identity management solution to do the authentication through ADAS in that sense. And at the same time, we have integrated a privacy preserving identity management component that is in charge of providing the right credentials or the concrete credential that the user later is going to push on his request to access to a certain kind of service in that sense. Okay. At the end, as I already mentioned, the demo that you will see later is basically showing an example of a visitor. In this case, we consider the case of a visitor from another Spain, but really, as you will see later, the access is the same that any kind of external visitor or foreign visitor will have. So he's going to connect to the platform. He's going to be enrolled in order to access to the services. For doing that, he's been authenticated using the ADAS, in this case, using the Spanish electronic ID card. And later, based on this, when he's enrolled, he already gets the credential, so that later he's able to access to the different service depending on certain policies, that the policy will request certain attribute, and the user will be in charge to decide if he wants to provide the attribute or not in order to get the service, as you will see in that scenario. So for the first example, it's basically the enrollment. That is the one that you can see here. Basically, I mean, it's not going to go in detail about the flow, but basically you will see there all the different steps that I already have been indicated. So first, an authentication using the ADAS. Secondly, the engagement on the platform and the privacy preserving identity management and the credential management. And finally, the access to the different services that the user will have. So in order to show that, let's see a video where we will present these steps. In that sense. Okay, so let me move a little bit just to skip the first part that is the typical about asking for the user and password. So let's go here. In a certain moment, I was at the user is sorry. No, sorry. Okay, the user is providing, he's making the enrollment, he provides the user password. Based on this, now it's go through the key rock, in that sense that it's a bridge in order to connect, to do the authentication with the ADAS. For doing the ADAS here, as you can see, just a minute, as you can see in this context, is the user is accessing like a European citizen. Based on this, we select that to be in Spanish. In that sense, because of being in Spanish, now it's being requested to introduce electronic ID. This is based on the existing solution that already is being provided at national level for authentication based on electronic ID. You provide, this is based on NFC. So basically you provide your electronic ID. This is being read by the mobile, and now you are being authenticated to the system through the Spanish system. So now you are inside, you are enrolled, and now you are able to access to any kind of service that you want to have on the platform. No? So the next step is that when you are enrolled, now you have the credential, now you access to the services. So the services, as you already mentioned, in any case, you will request to access the service. The service will ask you about certain, based on the policy, to provide certain attribute. The user will decide if he accepts to provide that attribute, and then based on the attribute, finally you will get access or not to the service, depending on the kind of service. So let's see, for example, one example of a service that is successful. Like in this case, if they want to access to the parking system available. In that sense, so the user click on the password, then it is being said that you would need to say that you are above 18. So based on this, it is the case. So basically, you are authorized to access the service, and the platform provides you information about, in this case, the parking slots that are available on a certain area of the city, for example. Okay, so that's the case that the system is correct. The other case is when there's a service that is being denied. For example, here the same stuff is you access to the service. The service, based on a policy, requests you an attribute. In this case, the attribute is going to be being a citizen of Murcia. Remember that this guy is coming from another city. So in this case, he's going to provide his place of living, and based on this, he will be denied to access the information about the counters, the water counters available on the city. In that sense. So let's check again also this scenario. In this case, okay. So here the same again. So let's check here. As you can see here, he's asking you the postcode. In that sense, so this is the attribute that is being requested, so that you will decide to provide. He said yes, I provide it, and then when I try to access to it, they check that it's not Murcia, and because it's not Murcia, then you are not authorized to see the different service available on your site. So that's conclude our demo. So basically, I think the important thing here is to demonstrate that we already have used several components that already have been developed in as part of the project. In this case, the privacy-preserving identity management solution, the use of the ADAS bridge node connection, and all of them has been integrated on one of the demonstrators, in this case of the smart city. And also now the main idea is to extend this functionality to other, also connection with another demonstrator, so that we can have a cross-demonstrator scenario where we can bring components from different demonstrators in order to provide, I would say, a broad scenario of the solution that CyberSec4Europe is giving on this kind of situation, like smart city and others. Okay, so that's for my side, and I give the token then again to finalize the session. Thanks.
Right. Thank you, Antonio. Thank you, Vincenzo. And can I change the slide? Can I get the presenter right?
Yep.
Right,
now
thanks.
you are.
Thanks. Right. So thanks again to all the speakers. If anyone in the audience wants to know more information about what we discussed today, we have 2 deliverables out from our work package, D5.1 and D5.2, which are already in the website of CyberSec4Europe. They list all the use cases and their requirements, plus the demonstration blueprints, so what the demonstration will look like, how they will work, which is part of which you heard about today. And our next deliverable will be due the end of January, in which we will present our validation of the first prototype. So thanks for joining the session. I'm sorry we went a bit overboard with the time. I've listed there the contacts of all the speakers today. In case you want more information, do not hesitate to contact us. And yes, thanks again for joining.